So we're going to look at one final example involving limits. Let's evaluate the limit as x goes to 1 from the right, 1 over ln x minus 1 over x minus 1. So if I plug in 1, I'm getting 1 over ln of 1 is 0, so I'm getting infinity minus infinity. This is a different type of indeterminate form. This is still an indeterminate form. You cannot determine the limit if it says infinity minus infinity. That does not mean that the limit is 0. So we're going to take our limit here. And the first thing we're going to do is we're going to get a common denominator. So the common denominator would be the product of the two denominators. So it'll be ln of x times x minus 1. And now that they have a common denominator, you can combine them. So you're getting x minus 1 minus ln x over the product here. And if we look at this limit, if you plug in 1 here, you'll get 0 in the numerator, and you'll also get 0 in the denominator, which means we can now use L'Hopital's rule. So we're getting the limit as x goes to 1 from the right. So I'm going to take the derivative of the top, 1. The derivative of negative 1 is 0, minus 1 over x. And then you're going to have to use the product rule in the denominator, 1 over x times x minus 1 plus ln of x times 1. And then you're going to see that we still get, so let's first get rid of our fractions. So what I'm going to do is I'm going to multiply by x on the top and bottom. So I'm essentially multiplying by 1. So I'm not changing anything. So I'm going to get x minus 1. And if I distribute this, it'll be x minus 1 plus x ln x. And if I plug in 1 into this, you're going to see that you still get 0 over 0. So let's use L'Hopital's rule again. The limit as x goes to 1 from the right. The derivative of x minus 1 is 1. The derivative of x minus 1 is 1 plus, and then you're going to have to use the product rule here. X times 1 over x plus ln x. And now if you plug in, so maybe we'll simplify first. 1 over, these x's cancel, so it's 1 plus 1, it's 2 plus ln x. If I plug in x equals 1, you're going to get 1/2. So in the end, this limit was 1/2. So it's really important if you get an infinity minus infinity, that does not mean that the limit is 0. What you need to do is you need to combine the two terms, get a common denominator, and then use L'Hopital's rule to calculate this limit.